Now, see a mutual induction, we have done self induction. Now, this is the next concept is mutual induction. Suppose you have taken coil 1 like this and which is connected with a cell and there is a key. This we can take as coil 1. There is another coil placed over here and here a galvanometer is connected through with the help of this coil here. Now, what you do, as you switch on here or that switch K is closed, current starts flowing through this coil and the value of current increases from 0 to maximum value. When 0 to maximum value current increases, the magnetic flux linked with this coil increases and in coil 2 as a result galvanometer shows deflection to the one side. Suppose let it be to the right side. Why does it so? Because when the magnetic flux linked with this coil changes or that is increases, there is an induced EMF in this coil which opposes increase of this magnetic flux. Similarly, when you reduce or that the switch is suppose opened, in that case the current reduces from maximum to 0 and when the current reduces, magnetic flux reduces connected to this coil 1. So, the EMF is induced in this coil which opposes this decrease in the magnetic flux and because of that deflection in the galvanometer to the other side. Initially it was to the right, so now it should be towards the left. So, this phenomenon of this coil is known as mutual induction. So, so now we can define it here like this. Whenever there is increase or decrease of the strength of current in coil 1, there is an induced EMF in coil 2 which opposes increase or decrease of the strength of current and this phenomenon is known as mutual induction. Now, magnetic flux linked with the coil 2 is directly proportional to current flowing through in the coil 1, that we can take as I1 and we can write phi 2 is equal to M21 I1. Here M21 I1 is known as mutual inductance of coil 2 with respect to coil 1 and if you are writing suppose I1 is equal to 1 ampere, then you can write phi 2 is equal to M21. That means mutual inductance of coil 2 with respect to 1 is numerically equal to the magnetic flux linked with the coil 2 when current flowing through the coil 1 is unity. So, this is about the mutual inductance. Now, we can also calculate induced EMF. Induced EMF can be calculated, E is equal to minus d phi upon dt. So, we can write minus d upon dt, that is M21 I1. So, we can write E is equal to minus M21 di1 upon dt and unit of the mutual inductance is, that is Henry and it is represented by H. So, the unit of the mutual inductance and self inductance is same, that is only Henry. So, now we will be calculating mutual inductance of the two coaxial long solenoids.